Hi everybody, so the next question gonna deal with waves, okay? So I'm originally from a city called Hadera in Israel, and you know there's a problem right now. A lot of people buying stuff on Amazon or on other platform in the e-market, e-commerce, okay? So people, the managers of malls and stuff like that shops need to find a way how to make it interesting to come to the shop, see there's a big good thing to see the product that you want to buy before buying it, but they still need to do something to pull the customer toward the shops itself. So, for example, in my town, there's something that called Kfar Hayam, and actually there's a pool inside it. There's a pool, and there's some wave maker machine, okay, some machine, fancy machine that actually makes wave, okay, moving inside this pool, okay. So that's good. The idea is to attract some surfaces to come with the board and start to surf. And around this place there's a lot of shops. So this is the question that I thought doing for you about this wave crazy machine. So let's try to understand how wave propagate inside water. But I want also to emphasize how actually waves moves, how functions. In math, I can describe them as moving things. So I want to do like a kind of warm-up before diving in the wave pool. Okay, I want to think about if we're gonna have something, let's say a stick. Okay, really, I want to simplify it as much as I can. For example, I have this y and x. Okay, this is a function of a stick that I have. I have some long stick, and this stick is moving in time. So this is the stick, okay? The function that describes the stick is y equal to third of x, okay? This is the function, that's how it looks like. And this position, this is where the stick are. This is where the stick are, that's the idea. And if this stick is moving in some velocity, let's give it a, I don't know, let's give it a what did I put here? V equals 6. I give it 6 meters per second. Each second, boom, is 6 meters farther. Boom, another 6 meters. Boom, another 6. You got the idea. So I want to know, this equation is not enough for me. This one describes how the stick looking in some moment in time. For example, t equals 0. And I want a general term, which I mean y is a function of x and t, okay, to know where located this idea, where located this stick. So if the stick after, let's say, 1 second should be in this location, right? Wait a second. So the stick should be at that location, right? So let's do a general term. So the way to do it is to put here, write the same idea here, and we know what is distance in time, right? Distance is x, and what is the distance that actually I moved? What is this distance? Is v multiplied by t. So I need to fix this term by minus vt. If I'm going through the positive direction, so this is gonna be minus, okay? That's the idea, okay, perfect. And so let's check that this term is true. So let's put, I wanna know, for example, my location after t equal 1 second. So it's gonna be 3x minus this is 6, this is 1, so minus 6, right? So it's gonna be third of x and then minus 2. Okay, let's see that this is valid, makes sense. So for example, at location 0, at the beginning I was here, but then whoop, if I continue, the stick is here. This is the reason you have minus, okay? And this location, all the dots went down. That's what I want you to see. And if I would need to move in that direction, it would be plus. So the idea is, the general idea of all this warm-up was to talking about moving functions. If I want my function to move in a constant velocity, all I need to do is take x and change it. If it's go through the positive, change it, add to x minus vt, and if you go to the negative direction of the x-axis, add plus vt. Okay, just the one that I must make sure that you are doing. So perfect. Let's clean the board and going back to my cool wave pool. Perfect. So this is the wave pool. I clean the shocks, we don't need them. And I also gonna do axis. So this is my axis, okay? This is gonna be the y-axis, and this is gonna be my x-axis. Okay, let's do it the other direction. Okay, mirror. It's gonna be easier for me. So it's gonna be x, it's gonna be y, and this is the wave. Let's do the wave. Actually, the wave should be in blue. So let's do this one in purple. This is gonna be in purple. It's not that important. This is the axis. Okay, x and y, and in blue we have the wave. So the wave have like this mountain and this mountain. Let's say this is 2 meters high and this is 1 meter. And what's going on to this wave? The machine is it's like shooting this wave forward. So this wave is actually want to move in some velocity. What's the velocity here? Half of a meter. Okay. In each second, the wave is moving another half meter. So this is the wave. So after some time, the wave gonna be here, right? Okay. And another thing, let's assume, it's true that you know the wave should also melt apart. Let's assume that the wave is like standing still, okay, and just moving. To simplify stuff, of course, we just need to change the function, but to make a simpler function, because the function of describing the wave, that's the function that describes the wave, this is the blue one, is already pretty complicated. So f as a function of x at time t equals 0, this one, that's the idea, equal to 2 exponent minus x squared plus e minus 0.2 x minus 3 squared. So you already see that this function is a little bit complicated, and if I want also to add the melting idea, I would complicate it even more, and it's unnecessary. It's not relevant to the class of physics 2. So I skip this part, and we're gonna assume that the wave staying the same, and sometime it's a good assumption. It's depending on how long is the pool. If the pool is 1 kilometer, it's not gonna be a good assumption, okay? But if the pool is really short, it can also hold and can be good assumption. Perfect. So let's continue the question. So the first idea is to apply what we did in the warm-up. What is the general terming time of where locate the wave? So where is the wave in space and time? Okay, so what we said, if we go into the positive direction, right, of x, we are moving in the positive direction, good. We just need to change x to minus vt to add, so it's gonna be f as a function of x and general t equal to 2 exponent minus x minus vt. Notice, I put it inside the x, so everything is going square, okay? The same thing here, plus exponent minus 0.2 x minus vt minus 3 square, okay? Really important. Done. Easy. That's the reason the warm-up was really important to me. Perfect. And the second question right now is at the specific time. Let's clean this one. The specific time. Okay, specific time. Let's say t equal 5, and at the location x equal 3 meter. Okay. How the wave looks like. Okay, so what do I mean? I mean, what is the height of the wave? I'm gonna go to here it is. For example, this is gonna be 3 meter at the this location, 3 meters. Okay, at time 5 seconds, t equal 5. How the pool look like? Okay, so this is how the pool look like at time 0, right? And this is a general thing. So what I need to do, I need just to plug these two parameters inside here. So if I take this one and put x equal 3, t equal 5, and the velocity which is given is a half. So I'm going to get the result that F is equal 1.84 meters. Okay, and I can do it for every dot. Okay, I can do it for here, for here, for here, for here, and I'm gonna get how the pools look like. Here it's gonna be 0, and here it's gonna be close to 0. It's gonna be like really close to 0, but here it's gonna be substantially higher. So this was the question. So it's really a math question. Just put the numbers, say that you're comfortable with it, and move on to the next one, which is what I'm gonna do right now. So you can feel free to pause the video and do the math. Okay, so the next question is, in the same spot, this location, and actually it's come up to be good for me, 1.84 is actually in the middle between 2 and 1. I want to ask you, what is the speed, the velocity of the water, okay? So I want to emphasize something, okay? The velocity in the vertical direction, okay? What I want to emphasize, look, this velocity is only at the x direction, but the molecule here, look what's going on. This molecule, this water H2O, right? This nice molecule, here's H, this is O, and here's F2H. A really happy water molecule is standing here, and it's in place, height 0. And suddenly this wave come, okay, to this point, and what's it's gonna do to the point? I imagine my head as the water molecule. Okay, so I'm here. I'm water, I'm fine, I'm not hydrated or something, I'm water. And then the wave come, and what's happened to my head? Right, so the dot of this molecule is actually lifted up. How it's lifted up? If it's this wave gonna come here, so it's gonna change the wave, change the height, right? That's what's gonna happen to this point. Okay, it's gonna go to 1 meter, go a little bit down, then go to 2 meters, then go fall apart. So they ask you in the next question, what is the velocity of this? Okay? So actually I drew it here, but I don't know. It could be also this one. This one is actually going up, right? Every second it's getting a little bit higher, and this one is actually going down because the wave is leaving this point, right? So this molecule is actually falling apart. So they want to know what is the velocity. So what is the velocity? The vertical velocity. So it's actually, if I want to know what is the vertical velocity, y, Vy, is actually the change in the location, y dot, right? Y dot is the derivative of y and time. So I know what is y, I know the f. So it's actually Vy is just the derivative of f, okay? By y, that's all. I know it f as derivative by, but at the end I want to put specific parameters. I want to put t equal 3 and 5 and x equal 3. So you need to derivative this term and put, it's really just math, like there's no understanding here, there's no physics here in the math. I skip this part and just tell you the main idea, the physics. So I'm gonna get positive number, which means that I'm going up, okay? I'm getting more and more speed. That's what it said. I get a positive number. I'm not slowing down, okay? I'm going in the positive direction. I'm getting height. This is what the mean of the positive, and it's 1.57 meter per second. So that's what I get. So this drop actually, whoop, going up. So this was the right guess. This one should have a negative, this should one have a negative sign, which means I'm going down and I'm slowing down. You see this slope is slowing down. This is actually the idea of derivative, the slope, okay? And okay, and the last question was about asking what is the idea of this number we just talked about. So that was this question. I hope the tutorial really helped you, okay? Wave is a super interesting phenomena, okay? And we're gonna continue talking about waves. The next subject is gonna be electromagnetic waves. And that's the reason we actually push this subject inside this class. Think about that we learn electricity, we learn magnetism, and suddenly we're learning waves. So what's the relation between these two? So there is a subject called electromagnetic waves, which mean it's a disturbance of electrical field and magnetic fields that moving through time as a wave phenomena. Okay, so we're gonna deal with that in the next class. So see you next time. If you like the video, put the like, subscribe to the channel, and thank you for the support. I really enjoy teaching you. So continue and start your homework, okay? And if something unclear, leave a comment, I will answer you, and feel free to ask. Good luck at the homework and with this class. See you next week.